Hi, everybody. This is Monica Paolini from Senza Fili, and today we're going to talk about the RU in within the Open RAN ecosystem. What's the role? What is potential for innovation that Open RAN brings about? And I have the pleasure to talk to Bill McKenney in the wireless communications business unit at Analog Devices about this. So, Bill, thanks for being with us today.
Hi, Monica. Thanks for inviting me.
So before we get deep into the ORAN and RU business, can you tell us a little bit about what is that you're doing, sort of the big picture from ADI?
Okay, so big picture. So ADI is a $10 billion technology company, and we're focused on that space between the physical and digital worlds, right? And what the organization as a whole does is we develop technology that senses, measures, interprets, and then connects the physical world with the digital world. That's what the whole company has been historically. It's been around more than 50 years. Back in the day, and even, we still are known as a semiconductor company, but more and more of our products are really digital based. And so we're that wonderful hybrid of programmed semiconductors, if you will, ASICs and things like that. Within the RU and within the wireless communications space, we bring really deep expertise in that area, especially in the RU, having developed the transceiver architecture that enabled sort of the current generation of radios, including massive MIMO. And that's through the integration of a lot of the components. Within the space also, we're probably the leading supplier of radio SoCs into the wireless infrastructure market. We have more than 60% share in 4G and 5G installations, for example, worldwide. That gives you a little bit of experience, understanding of who we are. And when I say we're focused on the radio unit, certainly in our group, there's an interesting nuance around that. We don't just focus on the technology that we're looking at or that we're creating. We don't just focus on that technology. We look at how that technology impacts that entire radio unit. And so that's one of the things that our customers have really appreciated as we integrate and innovate in our space, that we're doing it with an eye towards how are we improving the total solution, not just improving this segment or this semiconductor, for example, or that technology, that space.
Yes, and so that's really interesting the way you look at it. Like, you're the edge from virtual to reality. So, and there is a lot there. It's just not just the edge. It's right. Or at least it's a rich edge that you're working on. So so that's it's a very good way to think about, especially when you think about Open RAN, where everything is virtualized or potentially can be virtualized. You're just right. And so, can you tell us how is that? You said you've been working on this for quite a long time, 50 years. So how is Open RAN changes the way you are doing things, or how is that? What are the differences in the RU that come from using an Open RAN architecture?
So that's a really good question. I think one of the fundamental things is there's not a lot of differences. The interface between the radio unit and now in the 5G architecture, the distributed, the DU and the CU, there is that interface there. What the Open RAN and ORAN activities are really trying to do is standardize those interfaces. So I guess in that context, the radio unit itself, in theory, wouldn't change very much. But what we're seeing, I think, as we see the implementation of it, is that the radio unit is becoming, first of all, as you noted, it's they're virtualizing DUs, they're virtualizing CUs. You can't virtualize the radio unit because you've got to pick up those actual radio waves. There has to be an antenna, there has to be a way to convert it to digital, or you get nothing. So that's as far as like security, that's good for us. But what you're seeing is you're seeing inside that radio unit a better integration and application of technologies that may have been put in the DU or may have been put on, say, an FPGA. That those technologies are actually becoming more power efficient and more. I guess the word I'm looking for is that it's developing a radio that's overall more efficient. So it's lower power, lower cost, lower weight and size. And it's doing that through this sort of smart partitioning and sort of wise integration, if you will.
So are you saying that with Open RAN, you can be more efficient or lower power or, have a better performance?
Yes, I guess so. And I should sort of distinguish the legacy vendors in the market, the larger vendors that are there. They are developing very, very efficient systems, and the radios are uniquely designed, typically not open, but very, they're really quality machines. I guess what I'm saying is that the Open RAN movement is allowing more vendors to get to that level of better power efficiency, better performance.
Yeah, and I think it's a good way because sometimes there is a sort of, especially from people that criticize Open RAN, is like you can have Open RAN, but you don't have parity, parity in performance.
Right.
And
right.
What you're saying is that no, it's just like you're raising everybody to the same level rather than getting everybody down.
I think that's right, and I think that we'll probably talk about it as we get deeper into this discussion. But Open RAN is going to be a process, and so today we're at early on still, they're mediumly early on, and it's akin to Rome wasn't built in a day, and these technologies will be maturing over the next year, 2 years, 3 years, as we reach those levels.
Yeah, absolutely. And so let's talk about the process, because that's really, I think it's really interesting. It's not like an on and off thing.
Right.
We have to get there. So can you tell us what is your involvement? Let's just start. How are you helping the process?
Okay. That's where I spend a lot of my time. I'm not an engineer, so I'm not helping the process much, but I facilitate. So I think at ADI, we think we're a contributor into Open RAN. We're an ally for the companies that are looking to go in and start building products in Open RAN and develop technologies around that. And we're a technology partner within the Open RAN ecosystem or the ORAN ecosystem. So we're pretty well engaged in that process. We've been engaged, we were at the first meeting for Open RAN. It was in Los Angeles. It was an interesting time. We're actively engaged in 3 work groups in Open RAN, and those work groups and focus groups, some of them are focus groups, are designed around, they're organized around developing standards and essentially standards and definitions of what open means. And we're contributing members to 3 of them. One is the front haul interface. Another one is the radio unit one, which seems pretty obvious. The front haul interface is the core connectivity between the radio unit and the DU and the DU and the CU. So we're engaged in both of those. And then the third one, which is a little more unique, but is necessary, is the security focus group, which will be a working group going forward. Those are the areas where we sort of can help the organization identify standards that work for optimizing the ORAN architecture, if you will. So that's sort of our engagement with ORAN. As we think about what we're doing within those organizations, so we're again helping develop those things. Outside of it, our technology, we are investing in technology that makes it easier to design and build these advanced radios. That's probably the best way to put that. If you go back in our history, we launched this one transceiver 10, 12 years ago that integrated all these parts. We've been building that out and been improving that, increasing functionality as it becomes power efficient to do so within the RU. And that actually helps the open radio unit ecosystem develop radios, more efficient radios, faster, and with less total cost, lower weight, power, all that, those things.
And so, but I mean, clearly you work within the Open RAN, the ORAN Alliance, but also you work with partners, I guess, in addition, because having the interface is step number one and fundamental, but then you need to make sure that actually things work together.
Outside of working with the ORAN Alliance, we're engaged with partners at multiple levels. Silicon partners, we're designing very efficient radio units as reference designs, testing partners on confirming interoperability partners with virtual test equipment, and so simulated test equipment with Keysight and the others. And then stack vendors, for example, with Radisys is one, Intel's FlexRAN is another, where we are confirming the interoperability of the radio reference designs that we're developing, the radio unit reference designs that we're developing, all the way up the stack through the DU and then into the FlexRAN and CU network. Within that context, what we're looking to do is simplify the radio design process for the vendors that are building radios in the ORAN ecosystem. And we're also working with these silicon partners to offer the most efficient, the most power efficient and weight and cost efficient radios for developing these. And so that's we spend a lot of our activity actually meeting with companies that are, you know, on both sides of us to sort of see how we can optimize the radio unit.
Yes. So now let's talk about another dimension. Is in the RUs you can have anything from small cells, microcells, macro cells, 4G, 5G, massive MIMO. What's the most challenging in there? From an Open RAN point of view.
Right. From an Open RAN, I think from an Open RAN point of view, certainly the most challenging is going to be really high performance massive MIMO. And I think that the technology behind that, the merchant silicon necessary to do that, is oftentimes not readily available for the Open RAN market. And we've actually partnered with Marvell to develop a ASIC-based massive MIMO product. It's a reference design that an Open RAN RU vendor can optimize for production. And that's one of the devices that we're going through and actually going through this process on, with the goal of having an available massive MIMO 64T, 64R device that can, compete with the best in the world. And so that's probably the hardest one. Below that, I think high power macro cells offer a challenge. There's a couple of reasons for that. Part of it is they generate a lot of heat, and so you need to manage that heat. You need to optimize your efficiency on the PAs in those systems. And where we're helping in that area, it's sort of interesting. For about 6 years now, we've integrated digital pre-distortion, which is a way you improve the efficiency of the power amplifiers, the PAs at the front of the radio. And our current generation of silicon actually has very high linearization results that are coming out of it. And we've applied some machine learning and some AI techniques in it to get that. And so the net is what you end up with is you can run this very advanced DPD in merchant silicon, which is very low power, but yet programmable. And that sort of gives the Open RAN radio designer a leg up in developing these world-class radios. So they're getting the performance that they need with the operator customer it's going to meet what their requirements are.
So what is the timeline in terms of deployment? What is going to go first within these options?
So, as we see, this is the really interesting thing about the timeline. It's not a small lift for the operators to shift to this. The greenfield operators are doing it now, and so their timeline is today. They're looking at open massive MIMO systems, and they've got great open massive MIMO systems coming out now. I mean, there's the Rakuten solutions that are out there that are really getting a lot of deployments. Dish is going to be coming out with, I believe, Open RAN massive MIMO systems as well. They've selected a vendor for that. So there are vendors developing high performance massive MIMO systems, and they're getting out there now. But they tend to be larger companies that are already developing large radio systems. They're not more of the emerging radio developers, and that's where we think a lot of this action is going to be coming soon. Within that, there's a maturity that needs to happen within all of these suppliers and within the operators, certainly the existing major operators, as they prepare their networks for multiple vendors. And that's a very difficult thing. So first you'll see it in small cells, and then probably small cells and macro cells, and massive MIMO will, there are options out there. So you'll see that certainly in the greenfields are already out there. They'll be coming as well, but really the more proliferating RUs from the emerging Open RAN vendors will be probably small cells and macros initially.
Absolutely. So what do you hear? I'm sure you talk a lot to the operators. What do you hear in terms of the market drivers or their need? How are they driving? How are they making sure that they have what they need to deploy Open RAN? And again, more than the greenfield operators, which have a little bit, it's a little bit easier for them.
Right. They're those guys. So I mean, as I see it, and the greenfield operators could have an interesting competitive advantage for the window right now, because they'll be able to integrate these new networks that are going to be very flexible and offer more options. And I'm not sure where they're going to net out on total costs. Cost may not be lower that much. We don't think cost is going to be the significant driver here. We've been talking to operators since, about Open RAN since 2019, and actually 2018. And what I think my takeaway is that first, that they see it as necessary. They recognize and they are motivated to make Open RAN happen. And that was clear at the first ORAN meeting. ORAN is largely funded by the global operators. And the reason they need that is nothing against the legacy vendors at all. But they saw the political environment changing. There's this dichotomy or chasm, if you will, in the ecosystem where several of the large vendors, or a couple of the large vendors, have a difficult time competing in across borders. And the challenge with that is now you're limited to a very few number of vendors who are building monolithic structures, and that's a business risk for the operators. And I think that was probably the first thing that they looked at that is motivating them to change. That they recognize that there is a risk that they weren't controlling or managing. So I think that's part of it. I think the other that they recognized was that when 4G came in, really they didn't have the ability to respond to the changes that 4G brought into the system. The explosion of apps and media and services and all that stuff. They had no opportunity to recapture any of their investment in the spectrum and in building up the network to pay for all that. And I think that what they're looking for is a nimble network that's robust enough and an ecosystem that's robust enough that it can percolate products up in the same way that the applications business did under 4G. They're looking to have that happen in 5G and beyond. That there is an ecosystem of innovation that they can tap into to offer new services. Some of them monetizing, to monetize, some of them just to improve quality of service. New options, new business models, all of that stuff. I think that they really recognize that's an important thing. So that's how, that's where the need is coming from. What we hear from them is that it's for these legacy operators, it's a slow process. And the networks that they have, we think about them in terms of blocks and, big components of that are, oh, well, you just move a server around here and there. These are large integrated structures that are at a very large scale, very complex, and to change them is you need to do it in a scheduled and rational fashion. So we see 22 is we're seeing more movement in it. We're seeing more activity. Certainly, we're still seeing in the legacy operators just a toe in the water and just trying to understand where they're in there. They're learning about it. They're with Open RAN, they're in the ORAN Alliance. They're engaged in meetings on a regular basis. Their technical departments are deep in this. Their implementation is following that timeline. So that as the specifications are designed and confirmed, their technical teams are building it in the lab, testing it in the lab. They'll be doing test sites outside of the lab when it's mature enough along, and then they'll build that out. So as far as timing goes, we see 22 as sort of a first test, 23 probably more rolling out especially towards the end of 23, and then 24 and 25, we'll see. I think that's when the real Open RAN will be sort of introduced earnestly.
Yeah, absolutely, and I completely agree with you. It's just you should see it as a process, not as a switch,
Right.
and also not necessarily tied to a very short-term cost saving.
So I think it to cost, to your point on cost, I think you're right. It's as I look forward, that's where the opportunity for cost savings come in, and it comes in a couple of different ways. One is and it's following the same path that mainframe computers followed, that copier systems followed, and printing and all that. As the technology improves and disaggregation happens, costs go down significantly. And in this case, with the flexibility and stuff, revenue opportunities open up as well. So where do those cost opportunities happen? I think one of the interesting areas that is maybe the most hopeful is in OpEx and in energy. And I think 5G offers a really good opportunity for energy saving as we can sort of evolve away from the earlier legacy 2G, 3G, and eventually 4G networks and starting using the more efficient 5G networks. We see a 20x explosion in the data rates. We see a 90% reduction in the power rate type of thing. That's the promise of that. So I think that those are where the costs can be saved.
Absolutely. Now, let me ask you, what is special about what ADI is doing in this area? What's
I think
part?
Yeah, I think we're relevant in the ecosystem, in this Open RAN ecosystem, in a couple of ways. One is in the pure technology development. We're focused on providing, lower power, more efficient, more capable devices. And so last year we introduced an 8 transmit, 8 receive system on chip. That device, it provides 8 channels at wider bandwidth at the same power that the previous device provided at 4 channels. It included more functionality to simplify the design process for these Open RAN vendors. So it included, arcane things like digital channel up and down converters, or along with DPD, which we had sort of like an expanded digital pre-distortion process. We also include crest factor reduction, which is another linearization technique. We have some interesting technology on the bench now that will further integrate. We're developing an efficient lo-fi IP. It's actually in test, that will allow for a known, confirmed, verified, and tested path from the transceiver to the eCPRI out. All of those technologies simplify the design process for the radio builder, and in the end will reduce power, size, weight, all those lovely things.
So there is a lot for the operators and the vendors to benefit from.
Yeah, and that's right. And we're really focused on that. And part of the stuff that we're doing also isn't technology that we're building, but technology that we're partnering with other silicon vendors or other technology vendors that they're creating. And so I think together, we're again, we have a pretty focused area in the wireless network. We're in that radio unit. We are the experts on the technology within that. And so there are areas within that technology, within that radio unit, that we really work with our partners to help them, and together with them, we improve, say, efficiency. I'll give you an interesting story around that. We work with all of the major PA vendors, and because digital pre-distortion is an algorithm that sort of linearizes the PA. The way we work with them is when they're developing their next PA module, we get samples of that from them. We run it through our DPD, and we pre-linearize. We sort of set the parameters, turn the knobs, if you will, on our DPD to best optimize that PA, to get the best linearity and the best power efficiency out of that PA. But we don't do that one way. We share with them the results, and then together our DPD engineers work with their PA engineers, the different companies, and we look to improve the overall efficiency of that PA while they're still designing it. So they're making changes to their layout and their selection of transceivers at times, transistors rather at times, and we're simultaneously looking at how can we optimize or change maybe our DPD, or include more taps in or change the taps in the algorithm, and it's a back and forth process that can sometimes last for months, all with the ability to deliver a more efficient end result for the radio. So that's just one way that we work on that.
Yeah, and I guess it's as networks become more complex, you have to do more rather than less of that. That right. Working together with people. Right. Okay. Yeah. Well, Bill, thank you so much for sharing your thoughts with us today.
Thanks, Monica. It was great to talk to you.
And you can read a transcript of our conversation and get the full report on the Open RAN ecosystem from sensaphilly.com. Thank you so much for listening in.